Good morning, college algebra. This is Mr. Mazzola speaking from his apartment. We have an alternate method of instruction day. So thus, we are going to, or I'm making a video for you guys at least, and it's going to be a really fun one. There'll be two questions that I'll ask throughout the video. They're going to be random, so that way you can't just skip through it. So you have to watch the whole darn thing, which won't take too long because it's going to be a quick video because I'm tired. Anyway, in order to get your attendance points, I'll post a Google form and it'll have the two questions on there. Only it won't be like written out. It'll be like question one, and you'll know which question is which throughout the video. But there'll be two questions, so make sure you look through the video. And also don't forget to like, comment, subscribe. Hit that bell for notifications. Comment. There might be a giveaway, a gift card giveaway of $3,000. I'm just kidding. I don't have that much money. Anyway, let's get this video started and the show on the road. So we've already been talking about quadratics, right? So we have talked about complex numbers, and actually we're going to be graphing quadratics today. But, you know, I'm just going to save that for Friday, so don't worry about that yet. But do y'all remember that good old difference quotient we kind of touched on? Yeah, that's kind of important because if you remember from last semester, when we graphed quadratics, we had to find the axis of symmetry and then plug that value in to find your vertex. Now, the reason why the axis of symmetry, which is, spoiler alert, x equals negative b over 2a, that actually comes from that good old difference quotient we all hate. So, given a regular quadratic in standard form, ax squared plus bx plus c, you know, let's just for fun, plug it into that good old difference quotient. I know it's going to be obnoxious, but luckily my back's starting to hurt, so I'm going to be doing all the heavy lifting for you. Now, let's kind of take a gander when you plug it in. So a x plus h. So every time that f of x plus h came in, every time there's an x, remember just plug in x plus h. Plus b x plus h plus c minus f of x, make sure you use parentheses, ax squared plus bx plus c, all over h. And then we just start simplifying our way to victory. Now, x plus h squared, that's the FOIL question. But since I've done this problem probably a few thousand times in my lifetime, I kind of know how it's going to work out. So I'm just going to skip ahead. So ax squared plus 2axh plus 8h squared plus bx plus bh plus c, and then distribute the negative, ax squared minus bx minus c, all over h. And then there's going to be a lot of canceling here, right? So the way that these questions work out, because actually this difference quotient is just a really fancy way of saying slope, because these are your y. F of x plus h is your y2. That's your y1. And then h is actually the smallest. It's about 0, but we can't divide by 0. So in calculus, you get around it by taking a limit and yada yada. But it cancels out anyway, or it's supposed to. So let's just kind of see what cancels here. The ax squared does, the bx, and the c. So we're just left with 2axh plus ah squared plus bh, all over h. Now, everything has an h, so we can cancel those out too. So let me use a different fancy color. So now, we're just left with a 2ax plus ah plus b. Now, the calculus part is you take the limit as h approaches 0. So the one with the h in it still, we have an h squared, but one of the h's cancel actually goes away as well. And since this is a fancy form of slope, you know, this means that at any given point, you can solve for x and find out where that slope is at any given point. Now, let's say that the slope is going to be 0. Let's take a look. 2ax plus b. And then solving for x, subtract the b, divide by 2a, so x is negative b over 2a. Now, let's think about what a crop. Well, first, let me do the first question. Your very first question is actually the silly one. The second one's going to be a math one, which is going to come up in a little bit. But first question is, what is your favorite animal? And why is it your favorite animal? Make sure you put your name right next to it. That way I know, so you can take attendance for who came and who didn't come to class, you know? So don't spoil it to your friends, though. Have them suffer through this video just as much as you did. So first question, question one. What's your favorite animal and why? But now the second question comes in just a second. This looks awfully familiar, doesn't it? X equals negative b over 2a. Oh, golly geezer. That's your axis of symmetry, isn't it? AOS. Look at that. Isn't that fancy cool? That is not a quinkadink. There's actually a reason why. Now, and the second reason comes from, well, what does a quadratic look like, right? So let's think about what this quadratic looks like. So it could actually look two different ways, right? If it's face up, it looks like smiley. And if it's face down, it looks like a frowny. Right? But something's peculiar about both of these. Will be x equals negative b over 2. That's your axis of symmetry, meaning right here. Right? And that always coincides with this special point in the quadratic called the vertex. Now, if you were to graph a line or a tangent line, meaning a line where it just hits it once, so like this, then if you find the slope of this line, right? You find the slope of the line, that's positive right here, that's going to be negative here, because if you think about it just like a line, that's the negative slope, positive slope. But what if you were to graph a tangent exactly at that axis of symmetry, your vertex kind of deal? Now, spoiler alert, we already touched on it right here. What would be the slope of that line? And remember, this is just a fancy form of slope, right? It's the calculus form of slope. So there might be a kind of connection there. And your second question is to answer that. As in, question number 2 is coming up right now. What is the slope of a tangent line at the vertex of any quadratic? In other words, what would be the slope right here of this line? And why do you know that? And what connection? The second question is still going on. So what would be the slope of this tangent line right there at the vertex? And why is it that? And why is it connected to x equals negative b over 2a? So that's going to be your second question. Now, stay warm. I know it's stressful. It hasn't even snowed over yonder in Mr. Mazzola's world, so, but you know, snow is in the heart, so make sure you stay warm, answer these 2 questions, and you'll get your points. Take care. Make sure you do more pracky problems. Don't take a day off. No days off for math, because math is more important than everything. But also just take the day off too. So make sure you keep working with those complex numbers, and I will see you either Friday or Tuesday, and hopefully not at the Walmart I go to. So yeah. Peace. Ooh.